In 3.2, we're going to be working on writing algebraic expressions, and one big question that we're going to be trying to answer through our work is how can you write an expression that represents an unknown quantity? And again, variables are going to come into play with that. You don't have to copy this table down. If you think it's helpful, you're more than welcome to. You can also find it on page 120 in big green. But these are just a few examples of words or phrases for the different operations. And again, it's just examples. There are plenty of them out there to choose from that aren't on this list. And many of them I'm sure you're familiar with already. We know sum means addition, SUM, sum. And we know things like difference to mean subtraction. We've talked in class about of meaning multiply, quotient, those kinds of things. So there are plenty of them, again, out there that aren't on the list, but these are a few key examples as we start writing expressions that you might want to be on the lookout for. In example 1, we're going to be first starting with just writing numerical expressions. And numerical means basically just number. So no variables this first time around. We'll get into algebraic and variable expressions in example 2. For example A, they're asking us to write the phrase as an expression, and the phrase they give us is 8 fewer than 21. And lots of times this year we've talked about how when it comes to addition and multiplication, you can change the order of the numbers. It's not going to change your final answer. But when it comes to subtraction and division, the order matters. And so that's something we're going to have to pay especially close attention to on this one, because if you look at it, fewer than is probably leaning us towards subtraction. And a lot of us are going to see the 8 first, and we are going to see the minus or the 21, and we're going to see fewer than, and we're going to think subtraction. So we might write it like this, 8 minus 21. But if you think about it, 8 minus 21, that doesn't give us 8 fewer than 21. That actually gives us 21 fewer than 8. So you do not want to write it that way. Instead, you want to actually write it as 8 fewer than 21, meaning we started with a 21 and now we have 8 less or 8 fewer. So our numerical expression for 8 fewer than 21 would actually be 21 minus 8. For letter B, the numerical phrase they gave us was the product of 30 and 9. So again, keyword here, product means multiplication, and so you could write that as 30 times 9. Technically, since we're not in algebra, if you wanted to use the other multiplication symbols, you could, but in this case, we're not actually solving it right now. We're just writing the expression. So this would be our numerical expression for the product of 30 and 9. For example 2, we said we're going to be writing algebraic expressions, and remember algebraic means we're going to have variables involved. And so if we go to write the phrase as an expression, for letter A it says 14 more than a number x. And I know that's still probably going to take some getting used to for some of us, but remember a number x means that x is an unknown quantity. And again, we're not trying to solve for it. We're just going to write the expression. So technically we did say that with addition and multiplication, the order doesn't matter, but we still try to get as close to the meaning as possible. So if it's 14 more than x, it means x was our original amount, and now we have 14 more, so your expression should be x plus 14. And again, in terms of solving, if you were to switch the x and the 14 around, it wouldn't change the answer, but we still get as close to the original meaning as possible. For letter B, it says a number y minus 75, and again, order matters in this case, so it says a number y, which means we're actually starting with that one, because then it says to minus 75, so we would put it in that order, and our algebraic expression would be y minus 75. Letter C says the quotient of 3 and a number z, and again we should know quotient to be a keyword for division or answer to a division problem. So with division it matters, so if the quotient of 3 and a number z were to get written out, that would mean 3 would be our dividend, or our first number, divided by z, which would be our divisor. Or if you are trying to get used to the other method of writing division, you could also do 3 divided by z that way too. Either one would be completely fine, but the order matters. So you can't switch your z and your 3 around here or here without it affecting the meaning here. For example 3, we're still going to be writing an algebraic expression, but this time we're doing it from a whole word problem. So it says the length of Interstate 90 from West Coast to the East Coast is 153.5 miles more than 2 times the length of Interstate 15 from Southern California to Northern Montana. And then it says let M be the length of Interstate 15. Okay, and it wants to know which expression can you use to represent the length of Interstate 90, and it's a multiple choice, so you've got 4 choices here to look at, A, B, C, and D, and we have to break it down when we do these things and notice that if M is going to be the length of Interstate 15, and we know that we're talking about 2 times the length of that, then we would say 2 times M, and then to that, we would have to add the 153 and 5/10 to show that it's more than that length. And so if we look at that as our algebraic expression here to represent what our story problem said, so 2 times the length of Interstate 15 right here, and then the length of the West Coast to East Coast Interstate 90 is 153.5 miles more than that. So that's here, add that on, and you can see that that looks just like letter A right here. So you could go ahead and say that A is the correct answer that represents this story problem the best. For the last example, we're going to look at a real-life application. So it says you plant a cypress tree that's 10 inches tall. So that's the little picture over here. No, you don't have to draw the picture, but yes, you have to write the problem, please. And then it says each year its height increases by 15 inches. So for letter A, it asks us to make a table that shows the height of the tree for 4 years, and then write an expression for the height after T years. And remember, T could be any quantity, so it's obviously not going to be 4 years necessarily, but it means we could figure it out for how tall the tree will be at different years, like after 2 years, after 10 years, after however many years we want to figure out. And then asks us a specific question using that table, what is the height after 9 years? We can start to set up a table that looks like this, where we're going to put the year, which they said to use T to represent over here, and the height in inches over here. So when T would be equal to 0, we can start to fill our table in. That would mean after basically 0 years, or first when you plant the tree, that the height would only be equal to 10 inches, because remember they told us in the problem that when you plant the tree, it's 10 inches tall. So we start there, but then we start to look at different possible expressions that we could use here. So if the tree is 1 year old, and remember in the problem it said that each year the height increases by 15 inches. So if it increases, it's probably being added on. So we could say the original height was 10 inches to begin with, plus 15 more inches in the first year, and so we can just do 15 times 1, and that would give us a total height of 25 inches. Then, if we continue the same pattern, we could say in year 2 that it would be equal to the first 10 inches that it started with, 15 years, each year it grows, and if it grows for 2 years, we know that 15 times 2 is 30 plus 10, which would give us a total height of 40 inches, and you could just keep on going. If it were growing for 3 years, again, 10 inches to start, 15 inches each year. If it grows for 3 years, 15 times 3 is 45, plus 10 equals 55 inches. So you can see some patterns here. Each time the height is going up, it starts with the 10 inches and then it goes 15 more inches, but you multiply that by the number of years you're talking about it growing, and then you basically solve your expression for your final height. So this would be a table, and if we look at it that way, our expression then could be written as 10 plus 15 times t would be the expression here. And for letter B, it asks us to evaluate and figure out what the height would be after 9 years. So again, if we stick with that expression, we just wrote 10 inches to start with for that cypress tree, 15 inches each year it grows, and they want us to find out how tall it is after 9 years. So we'll do what we were doing in 3.1, which is just evaluate by making a substitution and sticking 9 in there for t, and then just using order of operations to solve it. So we would have to do the multiplication first there, and 15 times 9 would give us 135. And again, if you're not sure about that, please do the math and figure it out. And 9 times 1 is 9, plus 4 more is 135. And then don't forget about that 10 inches that it started with in the first place. So that means after 9 years, it would be 145 inches tall.